The while loop. What makes computers so useful is that they can perform repetitive computation without guidance. In this unit, you will learn the two fundamental commands that Java uses to represent loops. The first is called the while loop. Syntax is similar to an if statement. The condition is tested first, and if true, the body of the loop is executed. If it is false, the program exits the loop and continues on in the program. Below is an example of a loop that goes on forever. It will print out hello an infinite number of times. In computer programming, we must avoid creating infinite loops. They will crash your computer or the computer of whomever happens to be running your program. Loops should not go forever. There are 3 rules when creating loops. The variables in the condition must be initialized, the condition is tested before the loop begins, and at least one of the variables changes value within the body of the loop, eventually leading to the condition being false. Iteration statements, or loops, change the flow of control by repeating a set of statements 0 or more times until a condition is met. The condition, which is a Boolean expression, is either true or false, and its current value will determine if the loop should continue. The following example uses a variable to count from 0 to 9. The condition I is less than 10 is true as long as I is not 10. When I becomes 10, the loop terminates. I is initialized to 0. As long as I is less than 10, this line here will continue printing out the current value of I. Then I is increased by 1 prior to being tested again in the condition. Don't forget this step, or I will always be 0 and the loop will continue forever. Note, executing a return statement inside an iteration will terminate a loop and exit a method or constructor, which we will learn about later on. Programmers write the body of loops with an indent. This helps see what's in each loop and when a loop is within another loop. So here we have the indent for the body of the loop, and down here we have the same. But additional spaces don't do anything in Java. For example, to Java, the following loops all work exactly the same. So this example is the same as these. There's no indents, no new lines, and it's very hard to read. So always try to stick with end-of-line formatting or new line formatting. All of these loops output the same output. The indentation may not affect the computer, but it does affect our ability to read code. Always indent neatly. There are many styles. Pick one. You're not locked into any decision. Depending on the program you're writing, you may choose to switch styles. You will see this style a lot in this course because it's more compact. This is the end-of-line formatting, where the first curly brace is at the end of the line, where the while loop starts. But this style, new line formatting, is easier to read, so feel free to use new line formatting. So here, the opening curly brace is on a new line underneath the while statement. We have learned 4 ways to add 1 to a variable. I equals I plus 1, I plus equals 1, I plus plus, which adds 1 to I after evaluation, and plus plus I, which adds 1 to I before evaluation. While we will frequently use I plus plus, it is important to recognize all 4, because even if you always use 1, other programmers may vary, and you must be able to read code that someone else writes. We have also learned 4 ways to subtract 1 from a variable. I equals I minus 1, I minus equals 1, I minus minus, which subtracts 1 from I after evaluation, and minus minus I, which subtracts 1 from I before evaluation. Once again, it's important to know all 4 because you need to be able to read other people's code. When using a loop, one variable is always a counter, so that the loop only runs so many times. The variable starts with a whole number, counts by any number, not just by 1, and then ends with any number that does not satisfy the condition. In this example, we count from 1 to 10 by 1. So we start with an x value of 1, we add 1 to x over and over again until x is 11. When x becomes 11, it no longer satisfies this condition, and the loop terminates. Here's another example. This loop here counts from 5 to 15 by 2. So first x is 5, then x is 7, then 9, and so on. If you include a separate counter variable, you can compute statement execution counts and informal runtime comparison of iterative statements. A statement execution count indicates the number of times a statement is executed by the program. This can help you compare algorithms and their efficiencies.